In this video, I'm going to discuss the next type of reaction, that is decomposition reaction. Decomposition reaction is a reaction in which a single compound splits up or breaks down into two or more simpler substances. For example, let us say a compound is represented as AB. When it undergoes a decomposition reaction, it splits up or breaks down into A and B. Hence, it is represented as A plus B. This is just opposite of combination reaction. In a combination reaction, two or more simpler substances join together, combine together to form a single substance. While in decomposition reaction, a single substance breaks down into two or more simpler substances. These are also the examples of endothermic reaction. Endothermic reaction means the reaction in which energy is absorbed in some form. To break down anything, we need to apply energy. And for break down these substances also, we need to supply energy, and that energy is supplied in the form of heat, electricity, or maybe in the form of light. When we supply energy in the form of heat, such decomposition reactions are known as thermal decomposition reactions. While the reactions in which we supply energy in the form of electrical energy or in the form of electricity, such reactions are known as electrolytic decomposition reactions. And when we supply energy in the form of light, such reactions are known as photo decomposition reaction. So we're going to talk about these decomposition reactions one by one. Here, I'm going to begin with the first type, that is thermal decomposition reaction. So thermal decomposition reaction means the reaction in which the energy is supplied in the form of heat. The first example which I'm going to take, that is decomposition of calcium carbonate. Calcium carbonate has the formula CaCO3. It is available in the nature in the form of limestone. When it is heated strongly, it breaks down into two simpler substances, that is calcium oxide and carbon dioxide gas. Carbon dioxide gas evolves, is given out, and what we are left behind is calcium oxide. This calcium oxide, also known as quicklime, is used in different industries such as cement and glass industries. This is the reason why this reaction holds a lot of importance. So we obtain calcium oxide from nature by carrying out the decomposition of calcium carbonate, that is the limestone. This calcium oxide is used in cement and glass industries. I hope you remember, this calcium oxide or quicklime is also used in whitewashing the walls. So this is the first decomposition reaction. Moving on to the next one, that is decomposition of ferrous sulfate crystals. Ferrous sulfate crystals have got the formula FeSO4.7H2O. This is also known as hydrated ferrous sulfate. Now, what does this 7H2O represent? This 7H2O here represents the water of crystallization. It represents the water of crystallization. Now, what is water of crystallization? In class 9th, we had discussed the process of crystallization. So, when these salts, they are obtained during the process of crystallization, every molecule of salt, every formula unit of salt comes into loose combination with some water molecules. Here, every ferrous sulfate formula unit is surrounded by, is loosely combined with 7 molecules of water. and hence it has the formula FeSO4.7H2O. Because it is surrounded by water molecules of crystallization, it has the name, it is named as hydrated ferrous sulfate. It is also known as, because it is surrounded by 7 water molecules, it is also named as ferrous sulfate heptahydrate, where this hepta indicates 7 molecules of water of crystallization. It is also given another name. It is also known as green vitriol. Green vitriol, that is a common name given to this particular compound. Now, let's come back to the decomposition of ferrous sulfate. So when ferrous sulfate heptahydrate or hydrated ferrous sulfate crystals, they are heated strongly. Initially, this ferrous sulfate loses its 7 molecules of water of crystallization and forms anhydrous ferrous sulfate. So, how do we carry out this particular reaction? We take a dry boiling test tube. In the dry boiling test tube, we take hydrated ferrous sulfate. When it is heated, it initially loses water of crystallization and some water droplets are seen on the walls of the test tube. After some time, these water droplets will disappear because they will turn into water vapor. On heating further, this ferrous sulfate undergoes the decomposition, breaks down into 3 substances. One is ferric oxide, which is brown in color. Then 2 gases are evolved, sulfur dioxide and sulfur trioxide. Both these gases, they have the smell of burning sulfur. Both these gases, they have the smell of burning sulfur. So when we carry out this particular reaction, initially we find that when it loses its water molecule of crystallization, gets converted into an anhydrous ferrous sulfate. Initially, this compound, which was green in color, changes into white colored powdery substance, which on heating further decomposes into 3 substances. What are they? They are ferric oxide, sulfur dioxide and sulfur trioxide. So here ferric oxide is left behind in the test tube in the form of brown colored substance. We find some gases are coming out of the test tubes. Which are these 2 gases? These are SO2 and SO3, and these gases, they have the smell of burning sulfur, and we are left behind with a red brownish colored substance, which is ferric oxides. So this is how the decomposition of ferrous sulfate takes place. Children, when you prepare this particular reaction, do write it properly, note down the color changes. You need to know the color changes involved in this particular reaction. This reaction is very important as far as the exam is concerned. Moving on to the next one, that is decomposition of lead nitrate. Lead nitrate, it is PbNO3 whole twice. This is white colored substance. When this white colored substance is heated, it decomposes, breaks down into 3 substances: lead oxide, nitrogen dioxide and oxygen gas. This lead oxide, which is obtained, that is yellow in color. Nitrogen dioxide gas, that is obtained in the form of brown color fumes, and oxygen gas, that is colorless. So a single substance has broken down into 3 substances. What are they? They are lead oxide, nitrogen dioxide and oxygen gas. Lead oxide obtained is yellow in color. Nitrogen dioxide is obtained in the form of brown color fumes, and oxygen gas, that is a colorless gas. So as we had done it here in the case of ferrous sulfate, exactly in the same way, we take lead nitrate crystals in the test tube. On heating it, a yellow color substance is left behind, and we find some brown color fumes coming out of the test tube. So this is visible here in the test tube. We are able to see the brown fumes coming out, but how do we come to know that oxygen gas is also evolved? For this, we take a burning matchstick close to the mouth of the test tube. When we take that burning matchstick close to the mouth of the test tube, it starts burning more brightly, which indicates the presence of oxygen gas. Children, this reaction also, when you prepare, note down the color changes involved in this particular reaction. Moving on to the next one. The next is decomposition of potassium chloride. Potassium chloride, when heated, it breaks down into potassium chloride and oxygen gas is evolved. This reaction is used in preparation of oxygen gas. The next one, that is decomposition of zinc carbonate. Zinc carbonate also, when heated, decomposes to form zinc oxide, a solid substance, and carbon dioxide gases evolved. This reaction is used in obtaining zinc oxide from its carbonate ore. This zinc oxide obtained is then further reduced with carbon. So this was about the thermal decomposition reaction. We discussed about the thermal decomposition of calcium carbonate, where calcium carbonate decomposes into calcium oxide and carbon dioxide gas. The calcium oxide is used in the preparation of cement and glass. Then we discussed decomposition of ferrous sulfate. Ferrous sulfate crystals, green colored crystals, have the formula FeSO4.7H2O, which is also known as hydrated ferrous sulfate. When heated, they are converted into anhydrous ferrous sulfate, white colored powdery substance, which on heating further decomposes into three substances: ferric oxide, sulfur dioxide, and sulfur trioxide. The next reaction, that is decomposition of lead nitrate. Here lead nitrate decomposes into three substances: lead oxide, nitrogen dioxide, and oxygen gas. And the last reaction, decomposition of potassium chloride, gives you potassium chloride and oxygen gas, and decomposition of zinc carbonate gives us zinc oxide and carbon dioxide gas. This was about the thermal decomposition of these substances. Moving on to the next one, that is electrolytic decomposition. As the name itself indicates, electrolytic decomposition is a decomposition which is carried out by supplying or by passing electricity. So let me begin with the first one, the first example, that is electrolysis of water. When water, it is electrolyzed, when we allow the electricity to pass through it, it decomposes, breaks down into two substances. They are hydrogen gas and oxygen gas. The hydrogen gas is obtained at cathode, while oxygen gas is obtained at anode. Now, what is the arrangement? How do we carry out the process of electrolysis of water? For this, we take a plastic mug. This plastic mug, in this particular plastic mug, we drill two holes at the bottom, attach rubber stopper through which we insert our electrodes, graphite electrodes. These graphite electrodes are connected through wires to the two terminals of the battery. The electrode which is connected to the positive terminal of the battery is known as anode. The one which is connected to the negative terminal of the battery is known as cathode. Then we take water and to which we add few drops of sulfuric acid to make the water good conductor of electricity. Hence I have written here acidified water. After this, we put two test tubes which are filled with water. We invert them over these two electrodes, one at anode and the other one at cathode. Allow the electric current to pass through it. When you allow the electric current to pass through it, after some time you'll observe bubbles at the two electrodes. Also, you'll find that the water level in the test tubes starts falling down. As you observe this, you will notice that some gases are being collected in these two test tubes. Also, you'll find that the volume of the gas being collected in one of the test tube is double the volume of the gas collected in the other one. Slowly, as you collect more amount of gas, take them out, cover them up and check both the gases. Take a burning matchstick close to the mouth of the test tube. The one in which burning more brightly, that test tube contains oxygen gas, while the test tube in which the gas burns with a pop sound, that test tube contains hydrogen gas. So by passing electricity, we have decomposed, we have broken down, we have split up water into two simpler substances, hydrogen gas and oxygen gas. Oxygen gas is obtained at anode, hydrogen gas is obtained at cathode. Also, we observe that the volume of hydrogen is double the volume of oxygen. Why is the volume of hydrogen double the volume of oxygen? Because water contains 2 parts of hydrogen and 1 part of oxygen. Hence, the volume of gases collected in case of cathode, that is double the volume of the gas collected at anode. This is how we carry out the electrolysis of water. Now, one more example of electrolytic decomposition. Sodium chloride. It is taken in its molten form. Molten sodium chloride. And we allow the electric current. Again, we have the similar arrangement. We have the electrodes dipped into it, arrangement of passing electric current and so on. When we allow the electric current to pass through it, we find that this substance breaks down into 2 substances, sodium and chlorine gas is obtained at anode and sodium is collected at cathode. So, this is used in electrolysis of sodium chloride. Similarly, we can also use this in obtaining aluminium and oxygen gas from aluminium oxide. Aluminium oxide is Al2O3. In molten state, when it is taken and we allow the electric current to pass through it, it breaks down into aluminium and oxygen. Oxygen is obtained at anode while metal aluminium is obtained at cathode. This is how we can use electricity to obtain or to break down a substance into its simpler substances. We can carry out the decomposition by passing electricity. The next one, that is photodecomposition. Photodecomposition is a decomposition which is carried out by supplying energy in the form of light. Let us take the first example. That is of silver chloride, decomposition of silver chloride. Suppose in a watch glass or in a dish we have taken silver chloride which is in the form of white colored substance. When it is kept outside in the sunlight, you will find that after some time that white colored substance changes into grayish colored substance, grayish colored silver is left behind, and yellowish green colored gas, chlorine gas, is evolved. So we can write down this reaction as silver chloride breaks down into 2 substances, silver and chlorine. Silver is silvery gray colored substance, while chlorine gas is yellowish green. Similarly, silver bromide, when kept in the sunlight, this will break down into silver and bromine gas is evolved. Silver is silvery gray colored substance, while bromine gas is reddish brown. These reactions form the basis of, or they are used in, black and white photography. Because they show this particular property, they are used in these reactions, they form the basis of black and white photography. Also, when we store these substances, silver chloride, silver bromide, they are kept away from sun, they are kept away from light so that they do not undergo decomposition. They are normally stored in dark colored bottles. Another example of photo decomposition, that is decomposition of hydrogen peroxide. Hydrogen peroxide H2O2. When placed in light, it decomposes to form water and oxygen gas is evolved. This is the reason why it is placed in dark colored bottles so as to cut off the presence of light. So these were the examples of photo decomposition reactions. Moving on to the next one, that is some uses of decomposition reaction. We use it in the extraction of metals, that means to obtain the metals from their ore. For example, we carry out the process of electrolytic decomposition for obtaining the metals from their ore, such as molten sodium chloride. When it is electrolyzed, it gives us sodium metal and chlorine gas. Sodium metal is obtained at cathode and chlorine gas is obtained at anode. Zinc oxide is obtained by the thermal decomposition of zinc carbonate. Zinc carbonate, when heated, it breaks down into zinc oxide and carbon dioxide. Zinc oxide obtained is then reduced with the help of carbon. Next use of decomposition, that is in the digestion of food in our body. When we eat food, we eat food which contains starch and the proteins. During the process of digestion, these foods are broken down into simpler substances, such as starch is converted into simple sugars, while protein is converted into simple soluble form, that is in the form of amino acids, which can be easily absorbed by our bodies. So, this is another example, another use of decomposition reaction. This was our discussion about the decomposition reaction today. Go through these reactions carefully and practice. Thank you very much.